The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's Tech Talk on ongoing commissioning. My name is Sherry Adams, and I will be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined the Tech Talk, an attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing this icon allows you to minimize or maximize the control panel. When maximized, you can use this control panel to submit questions. We'll be gathering your questions throughout the Tech Talk, and we'll leave some time at the end for Q&A. If your question is related to a particular slide, please include the number of that slide in your question. A PDF of these slides for the presentation will be sent electronically to all those who have registered for today's Tech Talk. We will also be recording it, and it will be available on our website under the resource section. There is a new password to access the Tech Talks, and it will be emailed to all members after this presentation. Today's presenter is Jesse Securo. Jesse is a member of the International Board of Directors of the BCA, served as the subcommittee chair of the OCX Best Practices, and is a managing director for BGIS, leading operations for critical environments in North America. So Jesse, I'll send this to you.
Great, thanks Sherry, and thanks everyone for joining me today. I believe everyone's probably mostly working from home or in remote locations, and I'll apologize up front for any kids or dogs or cats that happen to come across the screen. But very much look forward to talking about ongoing commissioning. As Sherry mentioned, I've got a number of years of experience in commissioning and the building industry. Just as a little bit of a backdrop there, I started doing new construction and existing building commissioning about 15 years ago, and then quickly pivoted and moved more towards how we sustain performance in buildings using ongoing commissioning and what we were calling at the time active energy management, using metering data, building data, systems integration approaches to getting the most out of building performance over time. Over a number of years, I then shifted more of a role in facilities management and have been operating and maintaining buildings across America in my current role. Over the last year, I've been working with a subcommittee on ongoing commissioning, as Sherry mentioned, and recently published the ongoing commissioning best practices. Those best practices are the backdrop and really the foundation for a lot of what we'll talk about today. So with that, I'd like to just go ahead and dive right in, and then we'll collect any questions that anyone has and address those at the end. So OCX, another acronym for commissioning that we're throwing into the mix. We've had a number of approaches to commissioning over the years, and most recently have really centered on new construction commissioning, existing building commissioning, and then as technology has started to be leveraged, and as we look at how those commissioning practices can extend the performance of a building, we started talking about monitoring-based commissioning and ongoing commissioning. So I just want to briefly talk about how ongoing commissioning fits into the play here. From a new construction, existing building, I don't think that's going to be anything new to most of our audience here. New construction obviously being for new construction projects, major retrofits or additions to buildings where you're starting from the design standpoint, you're testing, you're starting up, and you're handing off a project based on the owner's project requirements and that initial design expectation for performance. As we get into existing building, that encompasses what we previously called retro commissioning and recommissioning. So it's a periodic check of that building, updating the owner's project requirements from a design standpoint to the current facility requirements, and then looking at how the current building systems and their performance support those current facility requirements. It's a periodic check on that building performance, and as such, there's a change in performance over time once we walk away from an existing building commissioning project. And that's where we start getting into ongoing commissioning, and it's this idea of how do we then use the building performance and our evaluation of it over time to sustain that performance. And we're going to talk quite a bit more about ongoing commissioning as part of this talk and as a process. But what I want to highlight here is the fit of monitoring-based commissioning as well. So when we talk about monitoring-based commissioning, we're really thinking about how we apply technology, the data that's available from buildings, the analytics of that data, and how that supports our commissioning efforts. From a technology perspective, and we think about monitoring-based commissioning, it really applies to all the different types of commissioning that are there. I've seen a number of technology platforms applied very successfully to new construction, allowing us to evaluate a large number of systems with a very efficient approach from a technology standpoint. Certainly is deployed as part of an existing building commissioning effort, where we're again using the data and the systems that are there and analytics on top of that in order to support that. And as we talk about ongoing commissioning, the monitoring-based commissioning approach and the technology approach definitely will be highlighted as an enabling tool as part of an ongoing commissioning process. And I really highlight that term process because that's what we're going to be talking about for ongoing commissioning. Okay, so one of the questions that we tackled when we were thinking about the best practices is ongoing commissioning a replacement for existing building commissioning? Can we do ongoing commissioning instead of other commissioning practices? And the short answer is no. When we think about ongoing commissioning as a best practice, it's really meant to follow on after new construction and existing building commissioning projects, where over a longer period of time, we're looking to sustain the performance of the building. And ongoing commissioning, when we think about it from a cost standpoint, we see initial build of a building, new construction commissioning takes place. We're optimized to design at that standpoint, but naturally over time, the performance of a building and the systems of that building will degrade. And that's where you get that baseline cost performance on the top of the curve here. We are seeing the costs increase year over year. What I've seen typically quoted is around 3 to 5% increase in costs as a result of degradation of performance. That obviously can vary quite a bit by building and the type of building, but that's a good benchmark to start from. The gray there, and where we get to that sawtooth curve, is when we start applying that periodic existing building commissioning, which from a best practice, every 3 to 5 years, we're going into a building and we're recommissioning it and getting back to a baseline performance, sometimes seeing slightly better performance over the initial design as we optimize to the current facility requirements. But you still see this degradation and increase in cost as a result of the time between those executions of existing building commissioning, where we go from a focus on performance to a focus on operation. And then the bottom line there is in the orange area is the efficiency that we really target from the standpoint of ongoing commissioning, that from a best practice, you do your new construction, you can flow right into an ongoing commissioning practice. Or if you didn't do that and you did see a degradation, you do your existing building commissioning, you fix what's broken, you address your major systems issues, and then you apply ongoing commissioning as a process to continue to optimize and sustain that performance over time. So at end of day, ongoing commissioning is not a standalone commissioning service. It's really meant to be done in partnership and in close collaboration with other commissioning efforts on a project. So I talked quite a bit about cost, and when we think about why we do ongoing commissioning, that's certainly a major driver, the reduced operating costs. From a standpoint of the ability of a project to pay for itself, the opportunity is definitely there. Recent studies by LBNL and others are quoting around 10% savings, up to 20% savings as a result of applying efficiency measures and focusing on cost-related measures that reduce your operating costs. When we think about the total cost of ownership of a building, a majority of the costs to begin with are on the operations and maintenance. So being able to optimize and focus on that efficiency is a best practice in and of itself. But the value of ongoing commissioning and why we do it doesn't stop at just the cost standpoint. There's quite a bit more related to what we focus on from an ongoing commissioning practice, other than just the building performance related to the cost that it has on utilities and maintenance side. From an O&M efficiency, we see ever increasing pressure to do more with less, that we see our operating teams being reduced in the funding that they have available and the staffing levels that we have within buildings. So from an ongoing commissioning standpoint, there is a big factor here in how we apply it to improve our preventative maintenance practices and strategies and reduce that pressure on the O&M team, as well as when we start looking at the application of technology and monitoring-based commissioning strategies. How do we use technology to make our teams more efficient? From a resiliency standpoint, I've worked with a number of clients related to critical environments where the cost was not the primary driver of ongoing commissioning strategies. It's actually on risk mitigation and how do we use ongoing commissioning to maintain the resiliency of our systems and validate that the systems themselves and the backup processes and systems that are there to maintain the uptime for critical environments. So definitely applicable when we talk about healthcare and data center type applications. The last one is always been part of our approach and thought process on why we do commissioning, which is health and safety. I think based on recent events and where we're at as an industry and focusing on the pandemic response, and as we look at what are the next steps to go back to a state of new normal and occupancy within buildings, health and safety is going to have a much bigger part of what we apply our ongoing commissioning practices to. Just from a starting point, looking at pandemic responses for HVAC systems and the need for relative humidity controls, and looking at targeting better bands for reducing the risks for virus spread, at that 40 to 60% relative humidity, the need to increase our outside airflows and increase the air changes in buildings. These types of indoor air quality practices are going to be part of our ongoing commissioning strategies to ensure that we're maintaining the health and safety of our buildings. And just not that it wasn't a focus before, but just a renewed focus and a high priority as we move forward. That's the why. When we think about how we apply ongoing commissioning, the ongoing commissioning best practices looked at it as a planning phase, an implementation phase, and a sustaining phase, and really looking at this as an ongoing cyclical process that there's really no start and end. It's a matter of developing your plan, implementing your plan, and then doing a periodic review. There's quite a bit within the best practices, and I provide the link and the reference at the end of this presentation, and really encourage people to reference that. What I want to talk about for the rest of our time together is about a couple core approaches and methods that are within the best practices, and really highlights the how-to on the ongoing commissioning. The first piece, and I've touched on this a bit already, is how technology plays a part in ongoing commissioning, where it fits, and how we use technology, but it's not a requirement in how we're applying the ongoing commissioning process. The second piece is making the most of our data. What are some very specific data recommendations that we've got on how we leverage what we have available to us and apply it to improving operations? And the last one I call sharing the reins, and we'll talk a little bit more about that here in a little bit. But the focus there is, when we think about ongoing commissioning, it's a little bit different than other commissioning processes. And the main driver there is that there's a much larger role that the operations and maintenance teams have in making the ongoing commissioning process and the success of it a sustained result. So those are the three areas I want to dive into a little bit more here. So we think first about process being enabled by technology. Now, I've said this a few times, that ongoing commissioning is the process, and just talking a little bit more about that. When we first started the best practices efforts, we were really starting to center on monitoring-based commissioning and defaulting to technology applications, and a number of references that are out there related to energy management information systems and how they apply as a tool and technology for sustained performance. We got challenged pretty early on by a few industry experts and people that have been practicing for a number of years, that ongoing commissioning, if you treat it as a process, it can really be applied to any building, any system, that you can take this as a process and apply it to pneumatic controls. You can apply it to that 20-year-old elementary school, and vice versa. You can also apply it to where you do have that technology. You've got a complete DDC system in place, where you've got a hyperscale data center with the latest and greatest technology for monitoring the performance of every system and component within that building. And that really changed our reference point. And from my own experience, kind of centered on that's absolutely true, that by expanding the scope of what we were thinking about as ongoing commissioning and thinking of it as a process and not a technology, that we were able to get to a point where, from a best practice, it's really something that can benefit everyone and has the ability to scale across those different systems and types of buildings. The importance here, though, is that no matter what you're thinking about from a technology standpoint, that you're focused first and foremost on the outcome that you're trying to get to. And the technology as an enabler certainly will change the depth and the detail that you can get into on what you're looking at from a building performance standpoint. But when you're scaling that and thinking about that K-12 elementary school on the left there in the image here, when we think about what we're trying to get to, we're trying to get to the right value for the client and thinking about how can we leverage the existing systems and at what point do we invest in additional technologies that are in line with what the school system would see as appropriate use of their funds and the value that they would get from an ongoing commissioning practice. So it may not be a full monitoring-based commissioning platform. It may not be a full DDC upgrade that you're doing right off the bat. It may be more of a manual process in order to get to that result for them. Conversely, when you talk to the data center client and the highly sophisticated buildings and systems that are out there and smart building technologies that are being applied, when that technology is available or when your outcomes are able to support that investment, then you're applying the applicable technology to those projects. The technology approach in the end of the day is being defined through a diagnostic plan. I want to talk a little bit about that. So from a diagnostic plan and what we've thought of here, traditionally in other commissioning practices, we call it a functional performance test, which is more of a point in time evaluation of a system performance with a functional performance test. As we thought about trying to wrap our heads around a functional performance test and ongoing commissioning, we pivoted to the thought that really it's not a set point in time, and we're really thinking about how readings and data use from a building apply to an ongoing test and evaluation of building performance. And that's where we pivoted from a functional performance test to a diagnostic approach to building performance. Now, from a diagnostic plan, one other really key area here is we've said you have to ask the question first, and then you design your system and how you're going to get that answer that you need based on the question you're trying to ask. And I've got a bit of a case study here, an example. A number of years ago, a decade ago, we were doing an energy project for Thomas Foley Courthouse. It was part of a number of federal government projects we were doing. And they had very significant energy performance guarantees. This one in particular, it was a 50% energy reduction. Right off the bat, we said we need to get the data necessary to understand end use, and we need that data to be able to understand when we have an issue and where that issue is. And so we identified 4,000 data points. We collected that data every 15 minutes, and at the end of the day, we had 90% of all end use loads monitored and submetered. Ultimately, though, when you think about how that adds up, it's over 140 million data points per year that were being collected. What we underestimated was the amount of effort that was needed to evaluate that data and determine what the priorities were within that information. And when we started looking at how we apply questions or analytics at that point to that information, it was a lot of manual efforts at that point. And that's a real lesson learned here that I've learned through that project, a number of other projects, and others have as well. And so when we think about a diagnostic plan approach and how we pivot that and capture that lesson learned, the diagnostic plan is really looking at what is the question you're trying to answer about performance, and then defining the data points, the frequency collection, and the analytics that you would apply to it in order to get to the answer. That really streamlines your design process and reduces your front end load on how you're designing your system and your collection practices for that data. It also really helps to keep everyone focused on the outcomes you're trying to get to. It doesn't limit you based on the technology either necessarily. So I want to just kind of backdrop this with another example. From an outcome-focused process, working with a higher ed client here in Western Canada, they've got a large campus of 20 plus buildings, and they've got it's basically buildings that are up to 100 years old, up to 2 or 3 years old. And within that infrastructure, they've got every type of system you can imagine, from pneumatic systems to full digital control to some newer projects that have a monitor-based commissioning application that came out of the new construction efforts. So really everything in under the sun from a technology standpoint. And at some point, ideally we would go to a full smart campus approach. That's certainly part of their vision that we'll be working towards. But in the meantime, it doesn't limit us in applying ongoing commissioning from a process. That there's still quite a bit that we can and will do from the pneumatic buildings all the way through to the buildings with the full analytics overlay. From the pneumatic systems, we're working with the client there on focusing on what I think many would call the low-hanging fruit, but it has a really big impact. So scheduling, temperature control, the pneumatic system efficiency itself. There's a lot of losses with pneumatics in general. The damper operations, which I'll actually talk a little bit more about with an example. Equipment cycling on and off. There's quite a bit that you can manage from a process standpoint and evaluate even with a pneumatic system that you're having to go into the field in order to validate or use data loggers to get that information needed. Once you get to the DDC systems and the digital control feedbacks, it certainly allows you to do a lot more. You're able to leverage trends and collection of trend information in order to basically evaluate that system performance more over time. You're able to start fine-tuning those systems, and you're able to really optimize them at a deeper level than what you would have otherwise with just the pneumatics. Similarly, once you get to the analytics standpoint, you're just enabled that much more. You're able to identify issues faster through notifications of performance issues. And one of the real things I like about the analytics side is that you're able to much better prioritize those efforts too. So you're able to collect, how often is that issue happening? You're able to couple it with utility costs and say, how much is that issue costing me? And how do I use that information in order to, based on the outcomes I'm shooting for, address that issue and prioritize it with the resources I've got. So nonetheless, though, I mean, despite the technology application there, we've seen significant savings. And again, a lot of that's driven by the low-hanging fruit, but it's still an application of a process to various technologies that's still getting us 10 to 15% or more savings across those buildings and those technologies. Diving just a little bit deeper on that example, talking about the diagnostic plan. As an example for outside air, it's a really common area that we see issues. Outside air dampers and their proper operation are really necessary for efficiency. Certainly from how we economize with that system, how we leverage outside air and free cooling. But there's also an area of high failure points. It could be a seized damper, could be a loose actuator, could be out of calibration temperature sensor. Any number of reasons cause an inoperable outside air damper, which then can impact your indoor air quality. If you're not bringing in enough outside air, it can cause a loss of efficiency and much higher costs if you're bringing in too much outside air or not enough during that free cooling. So, from a diagnostic plan approach, just outlining a couple of points here. If you're doing a manual approach, thinking about that pneumatic system, we think about what we want to monitor there and what that looks like. It is a very manual verification. So it's using your operations and maintenance team members through preventative maintenance to do a check. And I mentioned quarterly here. That's a good reference point to ensure that you've got proper damper operation during the season changes. But it's also, really dependent on how often you're seeing failures. If you've got relatively stable system and you're not seeing issues, backing off to a semi-annual would be appropriate. Or maybe it's more frequent and you're seeing a high failure rate of your outside air dampers and you're shifting to more of a monthly review. And even with the pneumatic system, there's quite a bit of capabilities to deploy data logging devices, hobos or others, in order to get additional data collection on the temperatures and the performance of that system over time. But that in the field check and looking at from a diagnostic standpoint, reviewing that the damper is closed when the system is shut down or when it's commanded closed. Likewise, when the damper is commanded to 100%, you're doing a verification of the damper position, and that you're seeing that modulation during an economizer control. So, through preventative maintenance and through a process, you're validating that damper, you're validating the performance of that system. When you see the automated approach, it's checking the same things, but the results are much different at that point. It's much more continuous, and it's more detailed in what it's able to evaluate. So from a monitoring overview, thinking about the question first, we're now looking at what data do we need in order to answer the question of, is that economizer working appropriately? So we're doing the demand, the damper command position. If it's available, we're doing the actuator position for comparison. We're measuring the significant temperatures, mixed air, return air, outside air temperatures. We're looking at the schedule of operation, And we're monitoring that at least every 15 minutes. Depending on the system, you may choose something more frequent than that. The diagnostic testing then that you're outlining in your plan is the analytics. It's the ongoing sequence that you would be testing to get the notification when you see abnormalities. So if you're seeing mixed air temperature varying from your return air temperature with the damper command closed, and that's happening for a period of time, then you're getting a notification. You're tracking how often you're getting that notification and the total duration of it, so you can get the magnitude and the priority of that issue. From a mixed air temperature variance that's much higher than your return air, you're seeing a potential issue with the damper as well. And so there's probably no less than half a dozen different types of analytics you can apply to this that uses the data available on an ongoing basis in order to get a good understanding of, is your damper operating in an ideal state? That's just an example of the pneumatic, more manual approach versus automated approach, but still looking for the same outcome, which is my outside air damper working correctly? Okay. Maybe just kind of blowing this up to the bigger picture and looking at this a little bit differently. So, you know, I see the diagnostic plan really as making the most of your data. One thing that I think is a good analogy here is, you know, if a tree falls in the forest and no one hears it, did it really fall? And the diagnostic plan and using that data makes sure that we hear every tree that falls. So just because that damper is not working correctly and no one was there to see it, it's still having an impact on performance. And through that manual check or an automated check, you're ensuring that you're able to see that. Likewise, I think the other really interesting tool here from a process standpoint is being able to see the forest from the trees and vice versa. That with the correct plan and the correct outcome focus, we're able to really think about what's going on in the big picture at the overall building, and we don't get so siloed in a system or a performance of a specific component. We're able to really think about how that applies to the bigger picture, but still be able to hone in and focus on the details where we need to. So just one bigger picture thought there. So beyond the diagnostic plan, the other area that I just wanted to touch on is sharing the reins and a really a different approach to ongoing commissioning from other commissioning approaches, which is the role of the commissioning provider. From an ongoing commissioning standpoint, there's a heavy involvement of the provider up front in the planning and implementation phase. So really developing that commissioning plan and the diagnostic plan as part of that to figure out, you know, what's the performance metrics that we want to measure. How does that apply to the outcomes of the building owner? And there is certainly an engagement from the building operator and owner in those initial phases to help identify those goals, leverage all of the knowledge capital of what's going on in that building right now, and how do we apply that to a meaningful plan. But as we get into the sustain phase and really from a ongoing transition to standard operations, there's this shift in the responsibilities from the commissioning provider to the building operator. And the intent here is that, you know, the commissioning provider is still going to be doing a check-in to make sure that the current facility requirements are up to date and assist with questions and support and ensure that the sustained performance results still align with that commissioning plan. But it's really the building operators that are taking the overall responsibility in that sustained phase in order to ensure that the best practices are applied and maintained over the long run. And so that shift in roles and the importance of the building operator is that much more for getting a sustained long-term result for the life of the building. Okay, that was the three major areas that I wanted to touch on around the process focus, the use of data, and the roles. I thought maybe just as we're closing some thoughts here, I'd leave some of my personal opinions on what does the future hold and what are we looking at from an organization for the Building Commissioning Association and for the, more specifically, the subcommittee for ongoing commissioning best practices. First wave that I'd say from a future standpoint is ongoing commissioning adopted more as a standard practice. The number of people on this call right now, the amount of interest we've had in the best practices and presentations on it, the interest is definitely there. We're seeing far more discussions of ongoing commissioning and the how-tos and where do we go for more information coming up that, as Nancy Benner originally focused on commissioning as business as usual. I think that's the next reference point for ongoing commissioning, that we're going to see it more adopted as a standard practice. We'll see ASHRAE updating guidelines and standards to incorporate ongoing commissioning as part of the reference tools available out there. We also would like to see, and we'll be looking at expansion of tools available for examples. So templates for diagnostic plans and templates for reports and ongoing commissioning plans that apply to ongoing commissioning. So that shift to standard practice certainly would be the first wave. I think the second wave will be having to focus more on the technology side. As much as I really value the focus on the process, and talked about that quite a bit here, there will be a point where we see the necessary move to technology as buildings continue to update, as the expectation on the technology as a tool is more prevalent. We're going to see ongoing commissioning become more synonymous with monitoring-based commissioning and merged more with the technology applications that are out there. The last wave I'd touch on is a little bit further down the road, but maybe not that far, is moving towards machine learning and artificial intelligence, where right now when we think about diagnostic plans and analytics, it's really what we think about and the questions that we can come up with that talk about building performance. The shift that we're going to see from a technology standpoint is where artificial intelligence can be applied, and we have the machine learning applications telling us what is the optimal performance and where are the areas of inefficiency and what does that mean. And so we're certainly seeing those advances in machine learning in other industries and technologies. As we apply that more to the building technologies, I think we'll see a third wave there that really focuses on the efficiency of data and analytics as more of a artificial intelligence application. Okay, before we get to questions, I just want to leave with a couple additional resources. Certainly the ongoing commissioning best practices, that's available. All of these are available online. There is a monitoring-based commissioning plan template by LB&L that was released a couple of years ago. Great reference too. It is more technology focused on applying energy management information systems and metering and data solutions, but it's a good plan template when you are applying technology. And then the last one is the Energy Information Handbook that as you're thinking about technology applications as it applies to ongoing commissioning or other commissioning practices is a great resource as well. So with that, I want to close things off and say thank you again to everyone for joining for the webinar today. Hopefully I was able to share a little bit more about some thoughts on ongoing commissioning that you can apply to your own applications. And with that, Sherry, I think we can open up to any questions that we have.
Yes, thank you, Jesse. We do have a few questions here. This first one came along at the beginning of your presentation, and it is the baseline cost performance the result if no form of commissioning is applied?
Yes, so that initial graph showing the increase in baseline costs is intended to show that 3 to 5% increase year over year with no commissioning or any sort of efficiency practices in place.
Okay.
Good question.
Okay, the next question is, do you include commissioning of the building envelope for any of your commissioning projects?
That's a great question. We're seeing a lot more come up with building envelope and the need for commissioning on a regular basis, not just from a new construction and design standpoint, but into existing building and into ongoing commissioning. I think we left the process open enough, certainly, to incorporate envelope testing and test and a process to apply that on an ongoing basis. But me personally, I have not seen ongoing commissioning incorporate envelope testing on a regular basis. I think the need is certainly there, and would definitely be open to discussions on what that would look like and how we would incorporate that more.
Okay, next question. What data analysis software do you think is used most often for OCX? And are there software packages that you see being used more often in the future of OCX data analysis?
Yeah, that's a tricky question. I actually was going to incorporate more on the technology standpoint and examples of analytics packages and monitoring-based commissioning tools, but intentionally left that out just so that it wasn't necessarily advertising for any one particular technology. There are a number out there. We've seen some more focus within the DDC providers themselves, but to be frank, I think most of the DDC providers are focused more on the operations and maintenance and control, and I've not seen them focus a lot on the analytics side. There's certainly project exceptions to that, but from a other technology standpoint, you know, this is not an advertisement at all, but just in my own personal experience, I've used SkySpark by Sky Foundry. That's a popular one out there. Copper Tree Analytics is another one that I've seen and used in the past too. Those are a couple popular ones, but they are by no means the end all of all the technologies. It's a bit dated, but you know, still a good reference would be that last document on here, Energy Information Handbook by LBNL. They had done an evaluation of a number of different technologies that are still very prevalent in the marketplace today. So for the person that asked that question or anyone else, I would recommend you look at the Energy Information Handbook and the technologies they reference there as examples.
Okay, they keep coming in. So what work is underway to get OCX into code?
Yeah, the best update I can give on that is ASHRAE is working on updates to existing guidelines and standards, and is considering breaking out a new guideline for ongoing commissioning. I think that would provide a great reference point for the industry to be able to adopt into codes and practices. The other area that I've seen advancing is pay for performance type programs through utilities. It's certainly not the same as codes, but it is shifting our industry and owners to thinking more about ongoing commissioning as a tool to leverage utility programs that are based on actual performance results and an ongoing verification of performance. Certainly measurement and verification applied to performance contracts would have requirements for how you're monitoring and verifying performance over time. That certainly is applied to ongoing commissioning processes. And then there's some very limited local geographic adoptions of codes that start to look at ongoing performance as a requirement for projects, but it's going to be very, very jurisdictional focused from what I see.
Okay, your economizer example appeared to be automatic fault detection, which I thought was MBCX based. Regardless, AFD is now a code requirement. Where do you see AFD fitting in OCX or MBCX?
Yeah, again, I think with the code requirements for automatic fault detection, that is going to be very jurisdiction and geographic requirement. Yeah, and I didn't touch on it that much, actually not at all, but FDD, so fault detection and diagnostics, automatic fault detection, a lot of these different approaches are very synonymous in many ways with monitoring-based commissioning, that it's using data, it's using a rule-based approach, and it's identifying diagnostics and a notification of a performance issue. When you see AFD being adopted by code, and where I think we'll see that continue to focus is more on where we see fire life safety and other requirements that require that level of investment in the technology to verify performance.
Okay, we have a couple more here. I'm trying to get through them all. Would OCX take the place of normal warranty review in the turnover phase? And what are some of the key differences or expectations when one plans to deploy OCX?
Yeah, so in particular for new construction commissioning, there is a warranty phase where we're doing testing specific to the review of a contractor's responsibility and identifying performance issues that can be addressed through warranty. Really, that typically I would see that as being a year or less, and so it's also very specific on an outcome related to a contract of deliverable. And so I don't see OCX replacing that warranty phase and the focus that the commissioning provider would have following a new construction project in validating the commitments of contractors in the performance of the building in initial turnover. Where OCX would support that is it would be a continuation of that, where beyond the warranty verification, beyond that 1 year, you've got an ongoing systematic approach to validating that that performance remains where you expect it, and that deficiencies that you may have through operations, through degradation of systems, through other issues that could come up in a building over time, then are picked up outside of that warranty.
Alrighty, if you have a few more minutes, I'll try to get through
Yeah.
one or two more, and then whatever we don't get through, if you're happy with or fine with, I'll send you out the questions, and we could do a follow-up email to anybody who didn't get a question answered here. But let me just see if I can get one or two more out. You see OCX blending to you see OCX blending to MBCX in future, agree, but what about now? LEED has OCX in Opt1 Path 1 and MBCX in Opt1 Path 2. What would be the major differences in these two plans today?
Yeah, to be frank, I haven't done a LEED commissioning project in a few years, so I'll start with that. But I'd say, the example here is where we're seeing that blend happening in the industry, that people see the technology approach being synonymous with the process approach. And I think, just as we stamped it from an ongoing commissioning best practice and current state, we really want to focus on it as a process, use it that way as much as possible. And if I had USGBC on the phone, I would definitely talk to them a little bit more about how we can center on current LEED standards being focused on the process first and foremost, so that it has the ability to scale and be applied despite the technology that's there. But I can certainly see too, from a validation standpoint, that there would want to be some sort of data-based and technology-based solution that backs it up too. So certainly a lot of blending there, and I can't tell you I have a definitive answer for you, but I would say focus first on the process and then focus on the technology that supports it right now.
Great, thank you. And then one last question, if we could get out, give your thoughts on predictive commissioning.
Thoughts on predictive commissioning? I think that's kind of going more towards the machine learning approach, and where we start seeing the analytics and the ability of the system and the software to be able to tell us what's going to go wrong before it actually goes wrong. I think right now, with what I've seen, a lot of what we would consider predictive commissioning is still what's in our heads and our ability to come up with those questions and program them into a sequence of operations applied to the notifications that we would get on an ongoing commissioning platform. I think true predictive commissioning would be being able to take information from multiple systems and really be able to analyze that data faster and smarter than what a person could. But everything I've seen from a software standpoint, we're still very much people dependent on being able to do commissioning, and I don't think it quite fits into that realm of predictive yet. Great questions, though.
Great, thank you, Jesse. We really appreciate your time and expertise. And as a reminder to everyone, we still are in our spring webinar series. There's 2 more webinars to be completed through this series, and all the information on them are on our website, and the registration is open for that. And on behalf of the BCA, I'd like to thank everyone for participating in today's Tech Talk, and hope everybody has a great day and stay safe. Thank you.
Thanks, everyone.